Hello, welcome back to online physics lesson. Today we will see equations for constant acceleration in one dimension. We are going to solve important equations for constant acceleration. The acceleration is constant, but we have a change in velocity. A body is said to be moving with uniform or constant acceleration if its velocity changes by equal amounts in equal interval of time. However, small this time interval may be when the body moves with a constant acceleration, the average and the instantaneous acceleration of the body are equal. They're equal, okay, with this constant acceleration. Only there is a change in velocity. Here are some notations. Here is t, the time, x, the displacement, v, the velocity or the average velocity. Here a, the acceleration. You can look this. It's already known. This change t. We can take it as by t because otherwise it starts from zero, okay, so we can take it as t. This change x is displacement. This change x is the displacement. We can write this equation as the change in displacement is equal to the x means the final displacement. We can write displacement final minus the displacement initial. Don't confuse, okay? No need to confuse because we are on the horizontal axis, uh, because the body is moving in the horizontal, on the horizontal. That means we put vectors on the xy plane. Don't forget, this is very important. This is the y, the vertical, the y, and the horizontal, the x. That's why we substitute the value x by and the value of s by x, okay, to show you the motion is in horizontal with constant acceleration, but there is changing velocity. If there is changing velocity, there is acceleration, but the acceleration in this case it's constant. And the change in velocity can be calculated by this one, the u v minus u initial. This can be written as the change in velocity is equal to v final minus v initial. Sometimes some books you may see v minus u initial. No need to confuse, okay? Just to say this, v indicates the final velocity minus u not the initial velocity. So in our case the acceleration is constant, okay? Now let us solve the first equation. Let us solve together. To get the first new equation, you know that the average velocity, don't forget this important formula, sorry. The average velocity, this v, is given by change in x, the displacement, okay? We can write this one, change in displacement by change in time. This can be the average velocity, okay? uh, you know can be written like this. Then from this average velocity we can find let me show you this one to make it clear. V average, okay, is equal to x final minus x initial. Okay, this x no need to confuse. Okay, to say the displacement final minus the displacement initial. Okay, or displacement final minus the displacement initial over time. No need to confuse. Okay, from this equation we can find x. X means the final displacement can be calculated by you can I can show you here. This implies V average is equal to the final velocity, sorry, the final displacement minus the initial displacement over time. It's crisscross this one over 1, the average velocity times t is equal to the final displacement minus the initial displacement. If you take this one, the initial displacement to the left side, what's left? V average is equal to, V average times T when the initial displacement moved to the left side, it becomes plus the initial displacement is equal to the final displacement. So this is the final displacement. It can be written as the final displacement because it's in x-axis is equal to the initial displacement plus the average velocity times t. We can write like this, or this equation can be written as the V average, or sometimes they put plus x naught can be the displacement initial is equal to the displacement final. These equations are the same. Okay, don't confuse S naught as initial or V or U naught, just to say the initial displacement and this one the final displacement. Okay, so this the average, this don't forget, this is very important. The average velocity is V naught, the initial velocity plus the final velocity over 2. Don't forget this one. So we already calculated the change in displacement, already, the displacement final minus the displacement initial, and the final position we already solved. The final we can write here the final. Our target is the final position. The final position is equal to x naught, x initial plus the V average times time, or you can write the displacement final is equal to the displacement initial plus the average velocity times t. Sometimes you get this one, but we are on the horizontal. All right. Now we have this example. Let's calculate the displacement. How far the jogger run? A jogger runs down a straight of road with an average velocity 4 meters per second for 2 minutes. What is his final position? Take the initial position to be 0. Let us see what's given. The first thing, take out the given. We have given the average velocity. This is the average velocity is equal to 4 meter per second time, which is equal to 2 minutes. Okay, in this case we have to convert the time into second. 1 minute 1 minute is equal to 60 seconds. What about 2 minutes is equal to how many seconds? Or let's say this one t. Let's say t. Now race course, this implies t times 1 minute is equal to 2 minutes times 60 seconds. This implies t is equal to, divide both sides by 1 minute, 2 minutes times 60 seconds over 1 minute, which is equal to 120 seconds. Okay, you have to convert minute into second. Then take his initial position to be 0. Another given thing is the initial position x naught, or the is equal to 0. What's required? Required is what is his final position. Already we calculated the final position can be calculated by the initial position plus the average velocity times t. Required, the final position is equal to how much? Solution. The final position is calculated by x, the initial position, plus, here look at this formula. Okay, we already solved v, the initial position, times the average velocity times time, don't forget. Times time. The initial position is 0 plus the average velocity is 4 meter per second times the time is 120 seconds. In total, which is equal to 4 times 0, 4 times 2, 8, 4 times 1, 480 second. The second is cancelled by this second. What's left? Only meter. That is the final position. Alright. Okay, let us solve the second equation. That means the final velocity. To find the final velocity, just start from the definition of acceleration. The acceleration is the change in velocity by the change in time. This can be written as the final velocity minus the initial velocity over already you can take it, change it as t. Okay, So which is equal to the acceleration. So from this formula, acceleration is equal to v final minus v initial over time. Now we can crisscross. That means acceleration times t is equal to v final minus v initial over nothing, over 1 already, nothing. The time is multiplied. Now from this equation, very simplifies, we can take out the velocity to the left side. That means acceleration times time v naught come to here, it become plus to the initial velocity is equal to the v final. We simplifies, v final is given by v initial plus acceleration times time. Already it's simple. It's the acceleration. Already it's a vector physical quantity. Good. Okay. Let us look at this example. Calculate the final velocity, okay, of an airplane, slowing it down after landing, okay. Just the airplane lands with initial velocity. Let us take out the given with initial velocity v initial is equal to 70 meters per second, and decelerates. That means the acceleration is decelerating, means we have a negative acceleration. That means minus 1.5 meter per second square for 40 seconds. That means we have also given the time is equal to 40 seconds. Now what is the final velocity? You are required the final velocity is equal to how much? First, let us see. The initial velocity forward. Now the acceleration decelerates. That means the direction to the back. Now solution. The final velocity is given by the initial velocity plus the acceleration times time. This can be calculated as let's write the value of the v initial, which is equal to 70 meters per second plus the acceleration minus 1.5 meter per second times the time is 40 seconds, which is equal to 70 meters per second plus this minus 1.5 times 40, which is equal to minus 60 second by second. This we have meter per second square, okay. Second by second, we have only 1 second, okay. Minus 60 meter per second, then which is equal to 10 meters per second. Okay, if you have any question, please write to me on the comment section. Okay, no need to stress. Okay, let's go to the next point. All right, here is another important formula that we are going to derive. Okay, solving for the final position when the velocity is not constant already, and the acceleration different from there. Okay, we are under a constant acceleration. Okay, we will find the final position, the x. We derive this equation. Okay, we are going to derive this equation. The first, we already know that the final velocity is given by this formula, and the initial velocity. Let us start step by step. Okay, let me with a new slide. The first, look, the final velocity is, already we know final velocity is equal to initial velocity plus acceleration times time. Okay, now we add here, it says add v naught, the initial, to each side of the equation. Okay, let's add the first step. We add this v final plus, we are adding the initial velocity for both sides, plus v naught initial plus this for v naught plus acceleration times time. Okay, sorry, this is a vector quantity. We add both sides the initial velocity, then divide by 2. Now we are dividing the whole equation by 2. Let us see what's happening. Now let us divide by 2 both sides. V final plus V initial over 2 is equal to, now we have to initial V naught plus V naught, which is equal to twice of V naught, twice of V naught plus acceleration times time over 2, because we divide both sides by 2. What's left? V final plus V initial. Writing the right in clear way. V final plus V initial over 2 is equal to this. We can 2 by 2, we can, in your mathematics it's very simple, V naught because 2 by 2, then 2 divided by acceleration times t plus acceleration times t over 2. We already divide by 2. Until this step, I think it's clear for you. Okay, now let's look again here. Since this part, this the average velocity is given by, we know that the average velocity is given by V naught, the initial velocity, plus the final velocity over time for constant acceleration. Then we already calculated, we have here come this equation is V final plus V naught over time over 2 is the average velocity. This is the average velocity is equal to V naught plus acceleration times time over 2. Until this, it's clear. And we know that we can write this one. we can write this one as the V average is equal to the initial velocity plus this 2, we can write 1 over 2 times acceleration times time. Okay. Let me, this I make a mistake because all right. Now we know that the final displacement is calculated as we know that here. Now we substitute the expression V into the equations for the displacement. That means you know this equation. This is the final displacement. The final displacement is calculated as the initial displacement plus the V average times the time. This already we already calculated before. Okay, so we substitute the value of the average velocity into this equation. Let us see. The final displacement is equal to the initial displacement plus the average velocity times the time. Now we substitute the value of the average velocity into this equation. That means we have here the average velocity. Okay, we substitute this equation into this. The final velocity is equal to the final displacement is equal to the initial displacement plus the average velocity is, substitute this equation, V naught, the initial velocity, times plus 1 over 2 a t, acceleration times t, the whole t. This is the value of the average velocity we already calculated here. Okay, now what's left? The final position is equal to the initial position plus t times v naught, v initial naught times time, plus t times 1 over 2 at t, which is equal to 1 over 2 times acceleration, take it as it is, times t square. This is another important equation. Okay, this is another important equation we already calculated. So next time I will bring one example for this final position. That's all today's lesson. It's enough because you have to practice. Okay, do it now. Okay, all right, it's good. See you in another lesson. Until then, bye bye.